Alright, so in this video we're going to be learning how to name organic compounds. So first of all, let's discuss what organic compounds are. They are large complex molecules which contain carbons and hydrogens. So let's just explain the structure of it first. It's made up of a carbon backbone where carbons are single bonded to other carbons, as well as hydrogens, which the carbons are single bonded to. On top of this, they contain functional groups, which are other groups perhaps containing oxygen, which are bonded to the carbon molecule, as well as side groups, which are, instead of the hydrogen, you might have other groups, such as halogens bonded to it. So the first step in naming the organic molecule is to count the amount of straight, unbranched carbons. So what straight, unbranched carbons basically means is that you can kind of draw a line across all the carbons because they're not branched or bonded to anything else. So, for example, in this molecule, we have, and you've got to do the longest unbranched chain of carbons. So in this molecule, for example, we have, if we do it this way, we have 1, 2, 3, 4 carbons. However, if we go like this, we have 1, 2, 3, 4, 5. So this gives us the longest straight or unbranched carbon chains. So in this one we have 5 carbons. Here in this example we have 1, 2, 3 along this way, or 1, 2, 3 along horizontally. So either way you have 3, which means that your longest unbranched chain could be either of them. It doesn't make a difference. So that's 3. In this final example we have 1, 2, 3, 4, 5. Even though it looks like the molecule is bent, it's not, because this is not a side group. The carbon is still single bonded to this carbon and does not have any bend in it. So you can still kind of draw that straight line along all those carbons. So that has 1, 2, 3, 4, 5 carbons, as we can see here. Alright, so once you've figured out the amount of carbons in the unbranched chain, so 5, 3, and 5, you have to match this with the prefix of the compound. So if it has 1, the prefix is meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, and it goes on and on and on. But for the purpose of this video, we'll just go up to 6. However, you just apply the same method if you have more than 6, like 7, 8, 9. Alright, so in this one, we have 5. So the corresponding prefix for that, 5, is pent. So the start of this compound would be pent. For this one, we have 3. I'll get a different color. We have 3. So 3 carbons gives us the prefix prop. So that would be prop, and then you'd add the ending. For this one, you also have 5. So 5 would give us pent. So pent. And then you add the ending on. So that's the first part of it, figuring out the prefix of the compound. Now the second part of it is to see whether the molecule has any functional groups. So, functional groups are basically groups attached to the carbon which kind of define what the carbon is. So here, since an organic compound is made up of carbon single bonds and then carbon to hydrogen single bonds, anything different is going to be the functional group, or it could be the side group if it's replacing a hydrogen and not a functional group. So once you learn the functional groups, you should be able to identify whether it's a functional group or a side group. So here, we have carbons bonded to carbon, we have carbon bonded to hydrogen all over here, and then here, we have something different. We have a carbon which is bonded to an oxygen, which is bonded to a hydrogen. So this is the functional group. So once you've memorized what groups are what functional group, you'll be able to define the compound. So for example here, I've written out that the rest of the carbon, the organic compound, bonded to the carbon, bonded to an oxygen, bonded to an H. See, carbon bonded to oxygen, bonded to hydrogen, is an alcohol. Carbon bonded to oxygen, bonded to hydrogen. So this is an alcohol. So I'm just going to write that here. This is an alcohol. And the functional group itself is called hydroxyl. So this is called a hydroxyl. The O to H is called hydroxyl. And this whole compound's class, here class, or which is like the type of it, is an alcohol. So now that you know it's an alcohol, you can figure out what the ending of this compound is. So here, as I've written here, the ending to any alcohol is anol. So when you figure out the longest unbranched carbon chain, which in this case is 1, 2, 3, so it is prop, 3-prop, then you can add on that prefix, which is prop, so I'll write that here, prop, and then the ending, which is anol, so propanol. However, there's one more step. You have to look at which number carbon the OH is bonded to. And you need to get the smallest number. What I mean by that is that if you start counting the carbons from this end, this will be the first, second, third. So if you start counting it from this end, the alcohol or the hydroxyl functional group is bonded to the third carbon. However, if you start counting it from this end, it's bonded to the first carbon. So therefore, since you're trying to get the smallest number, we start counting from here. And that means that the hydroxyl group is bonded to the first carbon. Since it's bonded to the first carbon, we actually have to insert something in here between the an and the ol. So instead of propanol, we have to insert in here which number the carbon's bonded to, which I said was 1. So propan 1-ol. And therefore, that gives us the name propan 1-ol. And that's the name of this carbon compound. Let's do another example. Here, I've got a different functional group. So we have C to C single bonds here. We have C to H single bonds here. But here we have something different. So here you have a carbon, which is double bonded to an oxygen. And then single bonded to an oxygen bonded to a hydrogen. So this functional group, you'll need to memorize and think, I've got it here. But basically, you can match this up and see that this is a carboxylic acid. See the double bond to the O and then the single bond to the OH makes it a carboxylic acid. So you know that this organic compound's class is a carboxylic acid. The functional group itself is called carboxyl. And the ending to it is anoic acid. So we have 1, 2, 3. So once again, our prefix is prop. So we have prop. And then we have to add the ending, which is anoic acid. Propanoic acid. In this case, the carboxyl functional group, this one here, can only be at the end of the compound because you can't put it in the middle. Because, for example, otherwise you'd have something that looks like this. If you try to put it here, how can you have an O and then an OH and then 2 more carbons on either side? So it has to be on the end of the compound. And therefore, it's always going to be on the first carbon. So we don't have to write propan 1-oic acid because it's assumed. It's always going to be on the first carbon, so you don't have to state that. So that's how you figure out the prefix from the amount of carbons, and the suffix, which is from the functional group. And then there's one more thing that we need to do to finish naming the organic compound. And that is adding the side groups. So with side groups, you can, when you look at the periodic table, you'll see these halogens here. You probably can't really see, but you have fluorine, chlorine, bromine, and iodine. And these ones can be side groups. So when you have a fluorine bonded instead of a hydrogen, and we'll have a look at an example in a sec. When you have a fluorine bonded to the carbon instead of the hydrogen, you have the prefix fluoro, which is just the first part of the halogen's name. If you have a chlorine bonded to it, then you have chloro, and this goes before the name of the compound. If you have a bromine, you have bromo, And if you have an iodine, you have iodo. So let's have a look at an example. Alright, here we have a chlorine bonded to the carbon instead of a hydrogen. That means we have to add chloro. Where did we add chloro? We add it before everything. So this is 3, so it's prop. It's an alkane. So we just add the ending ane because it doesn't have any different functional groups. It doesn't have any functional groups. So propane. And then at the start, we have to add the chloro because it's bonded to a chlorine. So chloropropane. And you have to add the position of where it's bonded. So it's bonded to the first carbon. We're not counting it from this end because then we'll get the highest, we'll get 3, and we want the smallest number. So we count from this end, and therefore it's 1. So 1 chloropropane. That's the name of this compound, 1 chloropropane. Let's do another example. Another side group you might have is CH3, and that's called a methyl side group. So here we have a CH3, which is a methyl side group. So it is bonded to the first, second there. Second. The methyl is bonded to the second carbon. So therefore we go 2 methyl, and it's an alkane. So and there are 4 of them. So butane. This compound is 2 methyl butane. Now let's put all of that together and do a larger organic compound. So here, I've got a larger organic compound. Let's do our first step, which is to count the number of carbons. So we have 1, 2, 3, 4, or we could count it this way, but we can just do either. So I'll do counting it this way. 4. Therefore, it is bute. The prefix of it is bute. Next, so that's our first step, counting the longest unbranched carbon chain. Now the second step is to see whether there are functional groups. And let's look for anything that's not the carbon single bond or the carbon to hydrogen single bond. And we'll find these are the side groups, remember the methyl and the halogens. But other than that, we have an O bonded to an H. And if we look back at our chart here, an O bonded to an H makes this an alcohol. So this compound, this class, is an alcohol. Therefore, it has the ending -ol. It is bonded to the first, second carbon. So we can put butan 2-ol. So that's the amount of carbons, the carbon chain. This is the functional group. This is the position of the functional group. And now let's look at the side groups. So we can see that there's a chlorine side group here, and that there's a chlorine side group here, and there's also a methyl side group here. So let's have a look at the chlorines first. So we had to start at this end so that the functional group would be on the second one, on the second carbon, rather than this end, because then the OH would be on the third carbon, and we're looking for the smallest number. So we start counting from this end. So this is carbon number 1, this is carbon number 2, 3, and 4. One of the chlorines is bonded to carbon number 1. So this chlorine is bonded to carbon number 1. We'll keep that in mind. This carbon is bonded to carbon 1, 2, 3. So this chlorine is bonded to carbon 3. This one's bonded to number 1. And then this methyl side group is also bonded to carbon number 3. So we have to put the positions of our things. So we have position 1 and 3 for the chlorines. So we will put 1, 3, 1, 3, and then we have not 1 chlorine but 2 chlorines, 1, 2. So that means that our prefix is going to be dichloro rather than just chloro because there are 2. So 1,3-dichloro. And then we have a methyl side group as well. So 1,3-dichloro, 3-methyl butanol. So let me just write that properly. I'll write that here. 1,3-dichloro methyl butanol. With this, of course, referring to the 2 chlorines, this referring, 3-methyl. With this referring to the methyl side group, and then the butan referring to the fact there are 4 carbons, and then the 2, and then the ol, which refers to the functional group hydroxyl, which is the alcohol, and then the 2, which is a position of the alcohol. So this video wraps up how to name organic compounds. If you need to go into detail about what the functional groups are, because there are a lot of different functional groups, check out that video, and thanks for watching.